Hello, everyone. So let's talk about water. We'll kind of see some terms about water, where all the water is, which type we use. And then later we'll talk about water pollution and human impact on water and how we are diverting the water and what are some of the solutions to it. So this video is just going to go over fresh water and the water supply and where the water is coming from and what are some terms in terms of groundwater, surface water, etc. All right, so freshwater systems. So the majority of Earth's water resides in oceans and it's too salty to drink. And only 2.5% of Earth's water is freshwater, and that's relatively pure and free from salts. So this is the ocean water, and this is the fresh water, only 2.5% of that. And of the 2.5%, 79 is stored in the ice caps and glaciers. Most of it's tied up there, and some is in underwater aquifers or underground water. So the surface fresh water is in lakes and in soil moisture that kind of drops as a rain. So we talked about water cycle before. So water is renewed and recycled as it moves through the water cycle. I'm not going to go into detail of water cycle. Again, you probably already know it because we covered it before. So participation falling from the sky, it sinks in the ground, acts as a runoff to the surface water bodies. And then the rivers interact with ponds, wetlands, and coastal aquatic systems. And then underground aquifers exchange water with surface waters. So what I'm trying to say here is everything is a one system. Everything is interconnected in this system. So participation or the rain from the sky either sinks into the ground, if you think about it, or it flows off to the rivers. It just kind of drains into the rivers. And then those rivers, they go take that water to the oceans. And I think I have a picture here. So, it's not really showing a rain coming down. The water sinks into the ground, drains off into rivers. These river flows into the ocean or lakes. As they flow, they can interact with ponds, they can interact with wetlands and aquatic systems, ecosystems. So, underground aquifers exchange water with the rivers, ponds, and lakes through the sediments on the bottom. We're now going to talk about marine and coastal components of the system, even though they are interacting, they are interconnected. That's a separate chapter, chapter 16, so you can read that in chapter 16. So whatever happens in one system affects others. So let's say if this river dries up, there will be no more water draining into the oceans. Groundwater is also flowing into the river and ocean. There's a dam that's blocking river flow and trap sediments in reservoirs. So if you remove that dam, something's gonna change. It's gonna affect the whole system. That's all I'm trying to say. All right, so groundwater, it's very important in hydrologic cycle, which is the water cycle. So there's two types. Surface water is the water located on top. That's the surface water. So for example, a river or a lake. Groundwater is beneath the surface that resides within pores of the soil. So that's the soil, and that's groundwater there. So groundwater flows slowly beneath the surface from areas of high pressure to low pressure and can remain underground for a long, long time. So this is a water table. It's kind of showing you what different things are called. I'm not going to cover everything, but these are porous. These are something called aquifers. These aquifers are porous formation of rock, sand, and gravel that hold water. It's like a sponge-like formation of rock and sand. And it's called, with an upper border called water table. So that's the water table. That's the aquifer, like a sponge. There's unconfined aquifer and confined aquifer. Um, It's just depending on um, which layer it's under. So that's how those terms are coming. So any area where the water can infiltrate through the surface and reach the aquifer is a recharge zone, basically. So when a porous water-bearing layer of rock, sand, or gravel is trapped between upper and lower layers, it's usually called a confined aquifer. All right, so surface water um, becomes groundwater by infiltration, and surface water just accounts for 1% of the fresh water on Earth. But it's so vital for our survival and planet's ecological system that anything we need it to be there. So basically, groundwater and surface water interact, and then water can flow from the one type system to the other. And then the groundwater becomes surface water through springs and human drilled wells. When we drill a well, people doing in Texas, that's how we get access to the groundwater. Water that falls from the sky, so the rain, melts from snow or glaciers, ice caps. They flow over a land surface called runoff. As it flows downhill, runoff converges where land drips between loess, forming streams, creeks, and um, other things. So these small water courses can merge into rivers, and then the rivers again can turn into lake or ocean. So area near a river course that's flooded periodically is called floodplain. Um, so right here in this picture, that's the river. These are Levi's. And here, this area is a floodplain. Because of the frequent flooding and depositing of soil makes it a very fertile soil there. So agriculture thrives in floodplains. And the area this here is called a riparian ecosystem or forest. Riparian is a type of ecosystem where you will see plants that has really big leaves, and the reason is because they don't have a shortage of water. So they don't have to kind of say we're gonna run out of water, so we should make smaller leaves. Because they have access to water, they make big leaves. So you find very species rich, very many species here in the floodplains because the soil is fertile and they have access to water. So lakes and ponds are bodies of standing surface water, and um, maybe you have heard of Great Lakes, North America's Great Lakes. Um, they have large volumes of water. So these lakes, they have a lot of ecological diversity. So they can vary in size, and you can see there's a different kind of organisms that are present there. So human activities, they affect waterways because we are continuously withdrawing water at unsustainable levels and we're depleting many sources of surface water. We are manipulating how the water is flowing. We are diverging its way. So the construction of engineering waterways like dams and canals has altered estimated 60% of the world's largest rivers. We are doing that, human activities. So this is what we're going to continue talking about in the next video.